What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it with class number 2 of 4. And we are jumping into critical concepts. I'm just going to post this on Discord right now real quick. Hold on, guys. And if you guys are joining right now, make sure to let me know where. Oops, hold on one second. Make sure to let me know where in the world. Oops, I think I put up the wrong. Oh, did I put up the wrong thumbnail? Hold on one second. All right, I'll fix it later. This is 2 of 4, not 2 of 7. Oops. Yeah. All right, so that's okay. I'll fix that later. But anyways, let me know where you guys are tuning in from. Where in the world, where in the country, all that good stuff. Okay, give me 1 second. I am going to just... I'm just going to post the link in Discord. If you haven't joined our Discord server yet, the link to join is in the description below. Okay, everyone. Okay, boom. So we got that up there. All right, ladies and gentlemen, welcome. We are continuing along for this October preparation of the October Digital SAT. And by the way, if you guys didn't know, I will be signed up and taking that test as well in October alongside you guys. So that's going to be really fun. Can't wait to check it out and see what's up. But today, what we're doing is we're doing a deep dive into critical concepts. So again, this is a 4-week program. So today we're going to do critical concepts 1 and 2. We're going to kind of have to race through it just a little bit, go a little bit faster than normal. And then next week, we're going to go through 3 and 4. That's going to be advanced math as well as geometry and trigonometry. Now, we also have a video going through all of these topics as well. So I'll jump around, but I'm going to post the video for all of the critical concepts, everything, 1 through 4 in one big video. I'm going to post that on the school platform as well, so you guys can go through that at your own pace and kind of jump through specific topics that you need to really firm up on. You can also ask me questions in this chat if you guys are joining here in real time, and I will answer as we go along. So we got a couple comments here. HQQQQQ says, got a 1500 with 3 weeks of studying as a junior after doing the old written tests and checking. How you did them in your past vids? Do you think it's worth to redo for a more competitive score? All right. So the question is, where are you applying? What schools you want to go to? Now, there are some college counselors that say to be competitive, let's say at Harvard, Yale, Princeton, some of these upper echelon schools, maybe you want to try and up that score to potentially a 1550 or above. I've heard that. I don't know if we have hard and fast evidence that 1550 is like a real cutoff, or it's sort of like in a bit of an imaginary cutoff or threshold that people have sort of discussed from talking to a lot of different universities, but it might be worthwhile, again, depending on the caliber of school you're applying to. Also, I'd love to know your breakdown. What'd you get in verbal? What'd you get in math? Because I do think the math is going to be a little bit easier to raise in a short period of time. So if you're taking the October or November, I think that might be that might sway me to say, hey, why don't you try and bump it up a little bit? Milan Thacker says, you think October will be easier because less seniors are focused on studying for it? Well, that is a bit of a misconception. It doesn't really matter, for example, how other people perform. It's not an actual curve. I've talked about this in a lot of videos. So for some reason, I don't know who began this idea or notion or rumor, but it got put into the ether that, hey, the SAT is curved, so if people do worse, it's better for you, and blah, blah, blah. It doesn't work like that unless the College Board is not being transparent about how they do the scoring and the grading. But assuming we can take them at their word, the way the curve is set, or the scaling, I shouldn't say curve, the way the scaling is set is it's predetermined based on perceived difficulties, a process called equating. So whether people do really well on it or really poorly overall collectively has no impact on the scaling of the score. The scaling is predetermined. So the College Board will sit down and look at the test, compare it to other previously administered tests and say, how does it stack up difficulty-wise? Oh, it's a little bit harder? All right, maybe one question wrong will still give you an 800, 2 will give you a 790. Oh, it's a little bit on the easier side compared to other tests. Maybe one wrong will give you a 780, and so on and so forth. So the scaling is predetermined. And how other people do is completely irrelevant. So HQ got a 760 in English. 740 math, you got a lot of room you could grow in that math. If you got a 740 with 3 weeks of studying, you could definitely bump that up. So I would say give it another shot and just triple down on math, especially if you're applying to schools that super score. You can kind of relax a bit on verbal if you feel like you need to do that to focus on math, but you could also try to bump that a tiny bit as well. But imagine you bump that math up. Now you got a 1540, 1550. I think that's gonna be important, and I think you can do it given the time you've already prepped, which is so little. HQ says, yeah, prioritizing an IV direct med program. I've heard that. Oh, okay. So people say that 1550 benchmark. Again, I don't know if that's how real that is because there's a lot of factors, and maybe that's a vast generalization, but a lot of college counselors say that over and over. What's up, Cole? Infamous Pants. Is there any way you can increase your mic volume? Oh, it's very low. Wait, let me see. Hold on. Oh, I got you. Okay. How about now, guys? Is this better? Is my mic volume better? Thank you for letting me know. Sorry about that. Hopefully this is a bit stronger. It's very weird. Sometimes in OBS, like the volume, I don't really change it. And then some days it's perfect. Some days it's a little low. And then I have to move it around. I don't know. It's weird. Let me see. So let me know, Infamous Pants, if that's good. All right. Let's jump into the mix. We're going to try and blaze through this stuff as efficiently as possible. And again, I might move a little quickly because we're in a time crunch based on my schedule today. And whatever things that I have to go kind of brush past, again, I'm going to give you the full-length video that you can watch at your leisure later on. We'll post that on the school website. Oh, couple of things, couple of orders of business before we get started. First of all, if you are looking for the best resource for additional practice tests, make sure to check the SAT Crash Course. You can see it up top here, okay? SAT Crash Course. Use the code SCALER for a 20% discount. Not only do they have 10 practice tests for sale right now, but they just are working on 6 new practice tests that we're going to drop very soon. I'm also going to have video explanations for all of those additional 6. I've already got video explanations for the previously released 10. So you can take the test, score them, and then you can watch my video explanations that are only available through that platform for every single one of those problems. So that's going to be a phenomenal resource. And Math Chops is also a great one as well. And last but not least, if you haven't joined our school platform, okay, that's where we're setting up the schedule. That's where we're posting the slides, practice resources, all that good stuff on the school platform. You can enroll. It's totally free to enroll, all right? The link is in the description below. Let me see how many people we've got in there right now. We got a pretty sizable class. I mean, not that big, but we got 473 members, so almost 500 members. Join the community, talk to each other, study together, make use of this amazing community resource, and be a part of this road to SAT success. All right, here we go. And by the way, verbal classes are on Wednesdays, taught by Dan Lerman, a professor of cognitive science at Columbia University, so make sure to join back on Wednesday for that. All right, so when we talk about algebra, these are, and this is 4 broad categories. And these subcategories are the subcategories that are presented on Khan Academy. So that's where I'm getting these subcategories. And sorry, these are the 8 subcategories. So we're going to kind of go through the critical concepts for each specific subcategory and move forward from there. Once again, let me know if you guys have questions in the chat. Infamous Pants says just a little more. So you want me to raise the volume more? Okay. Raise it a touch more. There we go. Hopefully that's better, guys. Let me know. All right, with the mid 740 in math, by the way, we got another question. With the mid 740 in math, what content do you think would be the best for me to use to boost? Oh, I've done all the old written tests now. You should, Truth gave a comment, but give me one second. So one thing you should definitely watch is this video where I'm solving the hardest problems, 38 hardest SAT math problems. One second. Okay. I am going to post this video first. Let me put it in the live stream. The other thing that you want to be mindful of is we're going to do more prediction videos leading up to the test, but my thought is that what the College Board is doing in real time is they're trying to create problem types within these subcategories still, mind you. It's not like they're going outside these subcategories, but within these subcategories, they're trying to create more problems that are not as easily solvable by just straight up plugging it into Desmos, which means what's going to be important is for you to have a solid grasp of the critical concepts that we're going to go over today, as well as the formulas that are on my formulas video. Have a really strong understanding and recall of these formulas. Hold on. So 34 Ascendant. I'm going to post that as well. Formulas, SAT Math. Okay. This is what I call my SAT Bible, digital SAT Bible. I had an old school version of it for the old test. Okay. Boom. So I posted that video in the chat as well. So check out both of those videos. Now Truth says, Huzefa, I'm very thankful of you because I got a 760. Let's go. What a great math score. That's phenomenal. 740 is great, by the way, too. You know, HQ, I don't want you to think I'm saying that's a bad score. That's a phenomenal score. But given that you did so little prep, you probably could boost it, is my assumption. Infant says, okay, that's better. May I ask whether this live stream will be saved? Yes, the live streams on this channel are going to be saved, so you guys will be able to have access to those. Okay. So first of all, we're going to talk about solving linear equations and inequalities. So it's all about, now this might be known to a lot of you guys, but as we solve or isolate variables, it's all about inverse operations, right? And inverse means sort of like opposite. Plus is opposite to minus, times and divider, inverse operations, square rooting and squaring, etc., etc. So as we see a problem like this in real time, we want to implement these inverse operations from farthest first, sort of like reverse order of operations. So one way to think about it is, hold on, let me get this thing going on here. So one way to think about it is like order of operations. We're square rooting first, then we're multiplying by 2, then we're dividing by 3, and then we're adding 19 to get 21. So to unwind these, to isolate, we kind of take care of those in opposite order, farthest first. So we're gonna undo the adding of 19 first by minusing by 19 on both sides. Then we're gonna get 2 is equal to 2 rad x divided by 3. The next operation that is farthest away, right? I said taking the square root, multiplying by 2, dividing by 3 is the dividing by 3. Let's undo that. The opposite of dividing by 3 is multiplying by 3. So we multiply both sides by 3. And then we get 2 square root of x is equal to 6. Then we're going to divide both sides by 2, undoing that multiplication. Then we get square root of x is equal to 3. Last but not least, we would undo the square root by squaring both sides, and we get x equals 9. Another thing to remember on the SAT as well with these types of equations, always make sure to plug back in at the end and make sure the answer works. Because if it works, then you're good to go. You're going to feel confident. All that good stuff. Make sure you don't make any mistakes, especially on free response. Got to do this. So check it out. Square root of 9 is 3 times 2 is 6. Divided by 3 is 2 plus 19 is indeed 21. Boom, done. All right. Let's clear this and let's move on. Boom. All right. Variable isolation, right? Combining like terms is also very important. So when we say combining like terms, what do we mean? Well, obviously here we have 3x and 2x. So the first thing we need to do is combine those, meaning consolidate. And the way to think about this is like, that's 3 of something plus 2 of something. How much will we have? Oh, 5 of that one thing, 5x. 5x minus 18 equals 22. Then we follow those same variable isolation steps. We add 18 to both sides like so, boom. And we get 5x is equal to 22 plus 18, which is 40. Divide both sides by 5, boom, boom. And we get x is equal to 8 for the win, all right? So there is our combining like terms. And again, when we're doing this one, it's the same idea, right? You're going to subtract 16, divide by 4, and you're going to get x is less than 4. That's how you solve an inequality, very similar to an equation. Okay, let's move it along. This is very important. When you divide or multiply both sides by a negative on an inequality, you must flip the inequality symbol. So for example, if I subtracted 17 here as we isolated, I get negative 3x is greater than negative 24. Now to isolate, we're going to divide by a negative, and you see we get x is less than, we have to flip it when we divide or multiply both sides by a negative, less than 8. And you can see this works. You can plug it back in. So less than 8, all right, well, let's try 7. Plug in 7. 7 times negative 3 is negative 21 plus 17 is negative 4, and negative 4 is indeed greater than negative 7. So you can verify, hey, did I flip it or did I not? Did I make a mistake by plugging in something within that zone? And we can see that that was done correctly. All right. Critical values. Now we're on to topic 2 or subtopic 2, linear equation word problems. And hold on one second. Just seeing if we got more comments here. Thank you so much, bro. You're welcome. Infamous says, when you say that College Board will be making it harder to just input something into Desmos and getting the answer, when do you think they will implement this? They already did. They already did this in August. Actually, I think they did this before, to be honest, even in June. So I think it's already happening in real time. Unless you felt differently about August, maybe, chime in if you did. But that's generally what I heard in terms of feedback about the test. So I don't know, though. I haven't, obviously didn't take it, didn't see it, but that's just what I heard through the grapevine. All right, so now let's talk about critical values for linear equations. So one thing to remember, The slope of a linear equation always deals with, if we're talking about word problems in particular, rate of change, cost per unit, things like that. So when they're asking you, hey, to interpret a slope value, meaning the constant next to the x, it should usually represent some sort of a rate or a something per something. My y-intercept is always going to represent my starting value, my initial value, etc. So for example, if they said, hey, to sign up for this service, you got to pay $10 down and then $3 a month. The y-intercept would be the $10 down, the initial payment, okay? And then the x-intercept, that's the point of zero value where y goes to 0. For example, an example of that might be, let's say you take a loan out, right, at $10,000, or let's just keep the number simple, a $100 loan, and you're paying $10 per month. You're repaying that loan $10 back. The x-intercept is going to be the number of months, at which you've paid off the entire loan, meaning you owe $0. Okay, so that can be what x-intercept might represent. And here's, of course, our slope-intercept form. And slope-intercept form is y equals mx plus b, remembering that m is your slope, b is your y-intercept. So let's take this example. For a training program, Juan rides his bike at an average rate of 5.7 minutes. Again, rate, that's probably my slope value, right? Which function models the number of minutes it will take Juan to ride X miles at this rate? So since this is a rate, I should see 5.7 multiplying X, right? So there's my slope. And the only one where I see that correct format, y equals mx, is, boom, right there, option D. Now you might say, where's my B? Well, my B is actually 0, right? If we're talking about the number of miles, it didn't say he's starting with 10 miles already done or 5 miles already done. We're starting with at point 0, no miles traversed. So that's why we would have a 0 value for B. Another example, here we go. Hannah deposited a fixed amount into her bank. They give us the function, and they're asking, what is the best interpretation of 25? So 25 is, again, next to the variable. So we know next to the variable is my rate. What about that constant? That's my y-intercept. That's my B. Now, it's out of order, but it doesn't matter. Commutative property of addition, we can switch them around, no worries. So when we're talking about interpreting the 25, it should be described as a rate. And with option A, it says each monthly deposit, it increased, it changed by 25. So that makes a lot of sense. Now, if we're looking at what 100 would be, if they asked us about 100, that'd be my starting value. So it said, before Hannah made any deposits, the amount in her bank account was, and if they said 100, that would be the right interpretation of the y-intercept. But they said 25, incorrect. That's how you do it. All right, moving along, we got another example here. So again, X is the monthly payment. What is the total cost to lease a car when the monthly payment is $400? This is a straight plug and chug situation. Okay, they're giving you an equation and they're telling you, oh, monthly payment is $400. X is the monthly payment, plug and chug, right? 400, or well, let's say 4 times 36 is 144, but they're saying 400, so add the two zeros, 14,400 plus 1,000, 15,400, excuse me, is that total cost, which would be C here, okay? Linear relationship word problems, hold on. How can I like this video more than once? Thank you, Nate. I don't think you can, but you can still keep commenting. That helps a lot in the chat. And spread the word, join the school community. Let's keep building that community of amazing, dedicated, devoted, awesome students like yourselves who are here joining along early in the game before this October test. All right, the number in front of each variable is the rate per variable. This is important, and this is something I've been seeing a lot on the digital SAT. It's just why I added this slide. So in this example, right, we're talking about a total of 70, and we're talking about 1 point questions per number of X questions. So what does that mean? I should see a 1 in front of the X, or nothing because it's an invisible 1. And then it says Y, and so I see that there, right? Just a single X. And then we got Y represents the number of 3-point questions. So since it's 3 points per questions, Y questions, I should see a 3Y in the correct answer choice, which I again see in option D, which means option D is the winner. Okay. Another example, and I'd love to get your guys' thoughts before I give the answer. Read this and tell me which one you think is the correct answer. I'll give you 1 minute. Let me know in the answers what you think, A, B, C, or D. Okay, so let's get into the mix. In this case, it would be, we need that 14, right? That's got to be there. It's equal to the total number of miles. I don't know where they got 112. So we need 14, and it's 3 per, right? So he walks for W hours, and then it's 3 miles per hour. So to get the total number of miles he's walked, it's 3 miles per hour, that rate in front of the number of hours, which we see in option A. And we also see R at 5 miles per hour. Again, that rate is the coefficient, 5 times R. Okay. And Truth asks, Huzefa, if I have seen your 7 days J.E.D.I, 7-part J.E.D.I course and solve the practice test with you, is it important for me to attend this class to improve my score? I would say the part about attending the classes live is it gives you an opportunity to ask me questions like you're doing now. But if you feel like you've sort of extracted everything you can from these lectures and from the videos, I'd say more importantly, it's time for you to now get additional practice resources. SAT Crash Course could be a great one where you got a fresh sort of collection of practice tests that you can practice with. But I would still watch the lectures if you can, because it's going to remind you of maybe some things you've forgotten, some things that fell through the cracks. Or just go back and rewatch the videos from the Scalar Learning channel as well, just to make sure you're fresh on everything. All right, let's keep it going. We got to hustle here. So graphs of linear equations and functions, right? We're gonna kind of jump through this. So again, my critical values, as I mentioned, we got the slope, which is rise over run. That's my rate of change, which we talked about. We got the y-intercept where it hits that y-axis, that blue dot right there. And then our x-intercept where it hits the x-axis, as you can see right there in kind of that orangish yellow color. Okay, now slope-intercept form, as I mentioned briefly, it's y equals mx plus b. Very important. M is the slope, b is my y-intercept. Once again, slope is rise over run, so we see right here. There's my rise over run. And once again, we got that y-intercept right there where it hits the y-axis. Now, in slope-intercept form, we got an example right here where we got a slope of 2 and a y-intercept of 3. And we can see that slope play out here, right? From one point to another one on the line, we're going up 2 over 1, up 2 over 1. And you might say, well, yeah, you're just picking points that have that relationship. What if you pick points that are farther away? Okay, fine. I could go here. Let me get the annotation tool. So I could go, fine. I could go up 4 over 2. That's not 2 over 1. Well, remember, slope is rise over run. 4 over 2 simplifies to 2 over 1. Even if I chose like really random values, you're going to always maintain that ratio, right? If it was like 5.2 over 2.6, it still reduces to 2 over 1. So at any point, it's going to have that consistent slope for these linear equations. All right, moving along. Now we also have point slope form. This is a very important formula as well. Y minus y1 equals m times x minus x1. This is also in my formulas video where x1 and y1 is any point. So we could have different versions of the same linear equation depending on which point you choose. And the slope will be the slope. Another one here, we have an example. So you can see the point here is going to be 2, 3, and the slope is 2/5. So there you see 2/5, and that point that's in there is 2, 3. Now, you could take another point, for example, and you could write this equation another way, and it would still be equivalent. Just to show you, we have a point here at -2, 0. So I could create the same equation on the line using that point. Y minus 0, that's the y value, is equal to same slope, 2/5, times x minus -2 would be plus 2. Believe it or not, this is the same as this. If I were to simplify this equation, distribute and all that stuff, it would work out to be the exact same as this top equation. So again, multiple ways to set up this equivalent expression. All right, or equation, excuse me. And then we have standard form, which is another way to present a linear equation. Ax plus by equals c, where a, b, and c are integers, and a must be positive. So this is in slope-intercept form. Here's the equivalent format in standard form. And if you ever need to convert from this to this, I'll show you the steps. Because sometimes they present answers in the multiple choice section in standard form. It's like, well, I know it's in slope-intercept form. How do I get it there? Let me show you. So first, you notice that x and y are on the left side. Let's do that here. So I'm going to add 2/3 x to the other side plus y is equal to 7. Then you notice like we shouldn't have any fractions. So sometimes people are like, well, so I multiply by the reciprocal of 2 over 3. Yeah, but then I'm going to have fractions elsewhere. Don't do that. Instead, just multiply by that denominator. So for example, I'll multiply everything by 3, bop, bop, bop. 3 times 2/3 is 2x. 3 times y is 3y, and then is equal to 21. And that's how we get our nice, beautiful standard form. Okay? Let's move it along. And here's an example of the line. Boom. There's my y-intercept, which you can see from the slope-intercept form. And again, there's my slope down 2 over 3. All right, moving along. Systems of linear equations. There's a couple ways to solve these. And you might say, well, hey, I can just plug it into Desmos now. I don't need to worry about substitution or elimination. Again, they're changing this test so that sometimes maybe they'll throw in a constant here. And you could still use Desmos. I'm not saying you can't. But sometimes they're setting up problems in such a way where the algebraic methods by hand on paper are going to prove to be more useful, more helpful than just throwing it into Desmos. So I just want to say it's still important to know these procedures. So for example, by substitution, I have y equals this. Let's substitute it in for y down here and let's solve. So we got 2x plus 1 equals negative 2/3 x minus 7, okay? And then now we substitute in, we can consolidate, bring x together. A little shortcut here not shortcut, but a way to make it easier by getting rid of that fraction. I don't want to add 2/3 plus 2. That's just a mess in my mind. Let's multiply everything by 3. Bop, 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 bop. I got 6x plus 3 is equal to negative 2x minus 21. Now I'm going to add 2x to the other side, 8x. Then I'll subtract 3. And that equals negative 24. Divide both sides by 8, and x equals negative 3. Now to find y, plug it back in to either equation. 2 times negative 3 is negative 6, plus 1 is negative 5. And now we got our solution for the system. And what is my solution? That is the intersection point. That is where these two lines intersect and touch each other. Solution, boom, done. All right, moving on. Next, we come to elimination, another great method. And by the way, some questions on the SAT are set up perfectly for you to carry out elimination. So it's just, if you remember this as opposed to having to type it into Desmos or do whatever, it's going to save you some time. So for example, if we're going to solve this via elimination, I'm just going to add these together in a way that one of the variables cancels out. Simple way to do that, negate, 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 add them together. Y plus negative y cancels out to 0. 2 plus 2/3 is 2 and 2/3, which is 8/3 x, and then 7 plus 1 is 8. Now, again, I don't want that. I don't like that fraction, but it is what it is. Now, minus 8 from both sides. Negative 8 equals 8/3 x. To isolate, multiply by that reciprocal of 8/3, which is 3/8. And then 3/8 of negative 8 is negative 3. These cancel out. And you see we get the same answer whether we use elimination or substitution. Again, to get the next value for y, we follow the same procedure. Plug it into either equation, and we get negative 5 for y. That's how you do it. Boom, done. All right, let's keep it going. I'm going to take questions in 1 second to respond to the chat. What's up, Turkism? Hello, hello. All right, give me 1 second. Here we go. And then, of course, we can solve it in Desmos. As I mentioned before, you would just type these equations into Desmos. You'll get the graphs. You'll see where they intersect. That's it. Okay, now we might come up with a question where they say, find a constant such that the system has no solution, well, one solution, infinite solutions. So just as a recap, if they say no solution, what we're looking for primarily is same slope, different y-intercept. What that means is you're going to probably want to get these both into slope-intercept form, and the constant will be like, there'll be some variable constant like a c or a d or whatever, that is going to be attached to the slope of one of the lines. Then you're going to, so here, let me give you an example, actually. It's probably too abstract if I don't write it out. Like you might, this is once it's in slope-intercept form, you might say y equals 3/4 x plus 7, and then the second one is y equals cx minus 3. And it'll say what value of c, this is an easier version, but what value of c will give me no solution for this system. And we're like, all right, we know the y-intercepts are already different. We need the slopes to be identical, so set c equal to 3/4, and that's the answer. But what you need to remember is like, all right, what is it? What does it mean when there's no solution? Parallel. What does it mean when there's one solution? Just different slopes. I don't care how different, they're just different. And what does it mean when there's infinite solutions? Everything is the same slope, same y-intercept. Okay, so here's an example, same slope, different y-intercept. Parallel, one solution, just different slopes. One is that one. Here it's -2, different slopes. We get an intersection point, boom, done. And that's your solution wherever they intersect. It looks like at 1, 3 there. And then infinite solutions, same slope, same y-intercept, meaning the lines are identical. If I divide the bottom one by 2, it will give me the same as the top line. So they're right on top of each other. That's infinite solutions. Okay. Next, we get to systems of linear equation word problems. Now, I solved this problem in another video. I'm going to kind of move a little bit quickly because you can watch this video explanation, I believe I think it's in my hardest SAT problems. This is also taken from one of the PSAT tests. I think it's PSAT 2. So you can see me solve it there. So I'm going to kind of move past it, but make sure you know how to solve these mixture problems from chemistry. All right, and then we have another one. This is a very interesting problem because you don't actually have to solve it. You just have to be able to set it up effectively. So check this out. We get two different relationships or equations. For example, first we get, recognize that X is the price of the shirts, Y is the price of the pants. And then we get these nice relationships. So 4 shirts, 2 pairs of pants is equal to 86. That translates to an equation of 4x plus 2y equals 86. That's what we're looking for. We're looking for these equations presented in the answer choices. We also have 3 and 5 equals 166, which should be in the correct answer choice. 3x plus 5y equals 166. So again, in these systems of linear equations word problems, you're not always having to solve it. You just need to identify what's the correct setup. Meaning, how do I translate a sentence into a math equation? Very important. All right, Z has a question. I'm going to answer it really quickly. He says, I'm trying to increase my score from a 710. Will these videos prove helpful for me, or should I work on the harder concepts? These videos will help you because, yes, I'm going over a lot of basics, but sometimes you may forget how to apply some of these basic principles in unique ways. So that's why I'm really emphasizing to everybody, my students, people in the school, classroom, etc., to get really solid on these foundations and principles, because it's like, okay, think about it like this. Some of the hardest quadratic problems on the SAT, they're really abstract, they're really crazy, but how do you solve them? It's fundamentals. It's knowing how to implement certain things in vertex form. It's remembering that the x-intercepts are symmetric about the vertex. It's knowing that in standard form, the y-intercept is the c value in standard form. So in order to put these relationships together, you got to know the foundations and the fundamentals. So I would say, yes, these videos are important, but I would also say go over my hardest 38 SAT problems solved in real, not in real time, but solved out step by step. So I would definitely do that as well, but don't skimp on the foundations and the principles. Do you have any tips on how to recognize when to use certain formulas in word problems? Or does that naturally come with, yeah, for sure. It naturally comes with understanding the formulas and what they mean. Now, as you go along and as you watch me solve these practice tests, you see that there's telltale signs. Oh, this is a quadratic. This is an exponential. This is a rational function, etc. So there are telltale signs, but recognizing that and applying in real time quickly is practice. Practice, repetition, watching me, rinse, repeat, so on and so forth. Okay. Linear inequality word problems. Again, we need to identify which way is that inequality facing, and also identifying these different parts, and once again, putting it into an equation or inequality format. So here we know X is the number of beads in the first, Y is the number of beads in the second. So let's look at the relationship. In the first container, we've got 30% of the beads are red, okay, and X is the number of beads in the first container. In the second container, 70% are red. So we should see something with like a 0.3 and a 0.3x and a 0.7y, which we see in option A. Now, when they say at least 400, that means that quantity should be greater than or equal to. That's equivalent to the wording at least. No more than would be less than or equal to. And just think about it like this. If you're ever wondering, hey, what does that mean in terms of inequality? Say well, if I said I need at least $100 to go to this restaurant or whatever to be able to afford a meal, what would that mean? Would $99 cut it? No, you need 100 or 101 or 102. So that immediately translates to greater than or equal to. Just think about it in a real life scenario and it will make sense. Okay. Here's a little table with some shortcuts for understanding what is greater than, less than, all that. So more than, greater than, right? Greater than or equal to, at least, no less than, that's your greater than or equal to. Less than is, of course, less than. Smaller than, also. And then less than or equal to, obviously, is less than or equal to. And then no more than, as I mentioned, or at most, that's a less than or equal to situation. All right. Now we move on to graphing these inequalities. So first of all, graphing regular systems, right? We just graph those lines as is, and we look for the intersection point. This is another way to solve a system of equations. If you graph it on Desmos or if you look at the graph presented. Now, graphing an inequality, it's like graphing a regular line, y equals negative 2x, but then we have to implement the shading. So it's very important to isolate y before you know where to shade, because otherwise I don't know where I shade, whether I shade above or below. But once the y is isolated, oh, it says y is greater than negative 2x, we're shading above, right? That blue section. And anything in that shaded region would therefore then be a solution. 5, 5, negative 1, 9, 1, etc. Now we got this one. Y is less than or equal to x plus 1. So we got the line y equals x plus 1. Less than or equal to, we would shade below, right? And why is this one filled in? Because of the less than or equal to, meaning the line itself is a solution. So it's a filled in line. That's how we do it. Anything in that shaded region or on the line, by the way, would be a solution. All right, last but not least, a system. We said y is greater than negative 2x and y is less than or equal to x plus 1. So we got both the shading, but where's the solution set? It's where we have the overlap of the shading, kind of like this purplish area, okay? So it's not just the shaded of the green or just the shading of the purple. It's the overlap or the intersection of the both. That's your solution set. So in there, 7, negative 2. In there, 8, 3, 5, 6 even on that line. But if we had something like this, are the following solutions. Let's check it out. 1, 1, yeah, that's in the zone. Double shaded region, boom, done. 5, negative 3, yeah, it's in the zone. And 5, 7, what about 5, 7? That's in just the blue section. So it's in red, that's no go, that's out, and that's how you do those systems. All right, we kind of blazed through that. Let's move on to topic 2. We're going to do our best to make it through as much of this as possible before I got to wrap. I have a hard stop at 3 because I have a session then, but we're going to do our best here. I'm going to post the video to all the critical concepts in this chat as well as on the school platform. Make sure to join our school J.E.D.I community. May the force be with you, and may you use the force for success on the SAT. Here we go. Problem solving and data analysis, a big category. Ratios, rates, and proportions is typically the biggest of these different subcategories, but here they are broken down, and we're going to step through all 10 as quickly as possible. I may not be able to jump through every topic in detail, but I'm going to highlight the very important bits and pieces. Here we go. So what is a ratio? It's also synonymous with a fraction, right? We could write 1 over 2 is the same as a 1 to 2 ratio, or you could literally say 1 to 2, okay? 1 and then the word 2. Here, let me show you what I mean just to make sure we're on the same page. You could say a 1 to 2 ratio, kind of like 3 different formats. Again, 4 to 9, we could say, or 4 to colon 9, and so on and so forth. We see this relationship play out again and again. And if we say the ratio of A to B, this is a really good practice problem to work on and get familiar with, because you might say, oh, A to B, it's 3 to 7, easy. Don't fall for that trap. That's a trap. If you want to know the ratio of A to B, since I mentioned A to B is equivalent to A over B, let's get this fraction, right? We got an equation. So we're going to divide both sides by B, cancel. And we got 3a over b is equal to 7. And then we're going to get rid of that 3 by dividing both sides by 3. Cancel. And now we see that a to b is equal to 7 to 3, meaning we have a 7 to 3 ratio. Okay. So this is a really good one to get familiar with so you don't fall for that trap, right? Divide by 3, boom, boom, boom. Divide by b, boom, boom. And we get the ratio 7 to 3. Distance equals rate times time. I'm going to jump through this. It is important, very important formula, but you guys have probably seen this in science class and math class, so you're familiar, but don't think it's an insignificant formula because of its simplicity. It's very important, very helpful. We're going to skip this problem. We're going to jump into proportions. How do you solve a proportion problem? Anytime you have a fraction equals a fraction, we're going to go with straight up cross multiplication. So this means BC is equal to AD. A similar example here, 1 over 3 is equal to x over 9. To solve for x, we cross multiply. 3x equals 1 times 9, which is 9. 3x equals 9, divide by 3, and we get x equals 3. Okay? We got another example. I'm going to skip through it. Again, you can watch this in real, like nice and slow and at your own pace. You know what? Let me post that right now. Give me 1 second. Digital SAT critical concepts. This is a massive video. I think it's let me see, 2 hours, 3 hours. All right. Yeah, and a lot of people are liking it. It's getting a lot of views, so or like steadily every week. So that's pretty cool because it's such a big video. Yeah, 2 hours and 21 minutes. This will give you the full breakdown, guys. Let me post it here in the chat. And again, I'm going to post it, as I mentioned, on the school platform so you can access it and review it at your leisure. All right. Anyways, moving along. We're going to skip this word problem. Again, that's just setting up a proportion. The important thing here that I'm trying to point out is you want to label your proportions. It's very important because you could just put 4 over 7 and then you're like, am I 5 over x or x over 5? If you don't label it, I don't know. I don't know what's on top and what's on bottom. But if you just do a little labeling, batches on top, tablespoons on bottom. Oh, 5 batches. So 5 goes on top, x goes on the bottom. Boom, done. This is a formula they keep testing on, at least on the practice test. So make sure you know density is equal to mass divided by volume because they don't provide it, but it seems to be popping up. I think it's going to show up on October. Could be wrong, but I would know this formula. Nice, simple, but I think it could be important. All right, you guys know dimensional analysis, how to convert. Again, so we set up the 2 miles to feet, then the conversion ratio. Why do I do 5,280 over 1? Because 5,280 feet is equal to 1 mile. And we set it up with miles on the top, miles on the bottom for the second one so that the miles cancel out. Then we multiply across and we get the equivalency in feet. Another example, same thing, a little bit more difficult, more played out, but we have 3 days converting to minutes. First, let's convert days to hours, right? We can do it step by step. I know 24 hours to 1 day cancels out the day is amazing. Now let's convert hours to minutes. Again, I know 60 minutes in 1 hour, so we cancel out the hours. Then we multiply across on the top, and we get 4,320 minutes in 3 days. That's a fun fact. Good to know. Let's move it on. Okay. This is a very important one because I see them testing this on the practice test. What about 2 feet squared to inches squared? So you might say, well, I know, a foot is 12 inches. So 2 square feet is just 12 square inches. Done, not done. So when you're doing this conversion, okay, you need to first look at the length conversion. All right, so it's 1 to 12. But to get the equivalent area conversion, just like we're taking square units, we need to square those values. So 1 squared is 1, 12 squared is 144. So 1 foot squared is 144 inches squared. Then you can just multiply it. So then 2 feet squared is 288. That's how you do it. Another example, if we're doing 3 meters cubed to decimeters cubed. Well, again, I know that 1 meter is equivalent to 10 decimeters. 1 meter cubed, we're cubing 1, which is 1. Then is equal to 1,000 because that's 10 cubed, 1,000 decimeters cubed. Now we can easily multiply this ratio, this proportion. So then 3 times 1 is 3. 3 times 3,000 is 3,000. So 3 meters cubed is 3,000 decimeters cubed. Okay, very important because I do see them testing on this, on those practice tests. So make sure you're familiar with not just converting length units, but taking the length equivalencies and extrapolating it out to area and or volume if need be. I'm going to skip through the percent stuff. You guys can rewatch this. You guys probably know the basics of percent. It's per 100 out of 100. Let me see if there's any new questions here. 1 sec. 1 segundo. Yep, no seconds. All right, let's keep going. And we got our percent equation. You guys may have seen this. I'm going to kind of jump through this a little bit quickly because you kind of know, like, hey, if we're taking what is 12% of 50, you're multiplying it by 0.12. Percent equation, again, watch my critical concepts where I step through this a little bit more closely. Stop me if you have questions. If you're like, hey, can you go over that again? I can go backwards, but just because we got 11 minutes yet left before I got to jump off. And, 9 is what percent of 45? Obviously, with this percent equation, it's going to give you the decimal equivalent. Just make sure to convert it back to a percent by basically multiplying by 100. And last but not least, if we said 30 is 75% of what? Oh, so the what number, that's our total. So we would say 75% of what number times x is equal to 30. And then to solve this, you divide by 0.75 and you get your nice answer of 40. Okay, percent increase. This is very important, guys. I see them testing on this again on some of these newer digital SATs, the distinction between 30% of versus a 30% increase. Okay. So we say it's 20% increase. We're not taking just 20% of 1,200. we're taking 20%, adding it on to the original value, aka taking 120% of 1200. So to do that, again, convert it to the decimal equivalent, 1.2. Then we just straight up multiply against 1200, and we get 1440. That's a 20% increase. Now, if we said a percentage decrease, 35% decrease, we're taking 35% of 1200 and then subtracting that value from 1200. Or you can think about it as if we're removing 35%, we're really taking 65% of that value. So again, that's 0.65 times 1200, which gives us a value of 780. Okay, move it along. Percentage increase versus decrease. So again, 120% of 50 means we just take 120% of 50, 1.2 times 50, versus 120% increase. That's a different scenario. So let me show you how you would distinguish between these two. And where it gets tricky, I think where it gets confusing is when you have values above 100. When it's less than 100, it's a little bit more logical. So 120% of, that means of is synonymous with multiply. So we just do 1.2 times 50, which is 60. But now it's 120% increase. So we still take 120% of 50, which is 60, but then it's increased. So it's in additional to, on top of my original 50, which is 110. Or the other way to think about it is you're taking that 120% and you're adding it to 100% or 1. So you're multiplying 50 by 2.2. That's another way to think about it. So whichever way method is conceptually easier for you to understand, I would follow that through. But both will give the same result. All right, let's keep it moving to the important stuff. You got to know this stuff, but this you can watch in my video, the distinction between mean, mode, median, and range. Definitely see them asking about range, mean, and median a lot. Mode, I don't see come up as often, but mode is the value that you see the most frequently pop up in a data set. And we also want to know standard deviation. Now, do you need to be able to calculate standard deviation? I will say pretty unequivocally, no. I have never seen them ask you to calculate it. Could they throw it out there? I highly doubt it, but it could happen. So just a caveat. But I don't think so. I think the main thing is you need to understand it. And understanding it means, what does standard deviation represent? The spread of the data. The more spread out it is, as we see on the left, the larger the standard deviation. The more tightly compact it is, the smaller the standard deviation. Now, one of the interesting things that they might throw out on the SAT is you might say we got values 1, 2, 3, and we've got, if I did it on a dot plot, we've got this distribution. And then we might see 21, 22, 23, and we have a similar distribution, right? And they say, compare the standard deviation. So you might say, well, these are bigger values. Maybe that means a bigger standard deviation. Wrong. It's the same distribution across the same exact range of data, right? So we got a range of 2, and that same lowest value, it's sort of like the exact same spread and then the exact same distribution. 3 there, 2 there, 1 there. So this would be equivalent standard deviation. And they like to ask questions like that a lot, where it's equivalent because it's different. Like the data is shifted, it's higher, but the spread is uniform, if that makes sense. So yeah, they ask that all the time. Okay, box and whisker plot. You got to know this. Let me explain the different pieces. That is the minimum on the left. That is the maximum value on the right. That middle thing is the median. If they ask you what's the mean from the box and whisker plot, you cannot answer that. Mean is not presented on a box and whisker. Then we have lower quartile, that orange section. We have the upper quartile, that section over there, that is 8 on the other end of the box. And then that entire length, minimum to maximum, of course, is the range. And then we got the inner quartile range, which is the green minus the orange, which is 4. Okay. Data representations. This is, again, I talked about this in the first one, in the first video in algebra. Slope is rate. You know, when it's positive, it's increasing, negative, decreasing. We talked about all this stuff already, so I'm going to skip through it. Again, we've got increasing on where that's a positive slope for a quadratic. Negative is where it's, you know, negative slope is decreasing. All that good stuff. We're going to keep blasting through that. Oh, yeah. For quadratic, the vertex is either going to be the min or the max. Here, it's the max because it's going down. But if it was oriented the other way, it'd be the minimum. Let's skip this. You can watch this in my critical concept video where I go through that one carefully. This is an x-intercept question. What's the best interpretation of the x-intercept? Remember I said it's the point of 0. In this case, since it's profit, that's the point where you're getting no profit. So if we look at the answers, okay, let me see where I see that answer about break. Okay, see this term. I saw somewhere breaking even. Where did it say? breaks even. The department breaks even if the manager stocks 300 pairs. So that's a weird term. You may not have heard that before. Maybe you have, especially if you're maybe not a native English speaker. Breaking even means zero profit. Means your cost is equal to your revenue. So you don't lose any money, don't make any money. But anyways, D would be the winner right there. Boom, done. Oh yeah, also at 900 too. I missed that. Y-intercept question, again, knowing that relates to the starting value, which is right there, so on and so forth. Line of best fit is important. That's just basically making a line right through the center of all those data points on a scatter plot, and then interpreting it. That's what you're doing here. Hold on, let's keep it going. So in this one, right, you'd have to draw in a line of best fit. You can clearly see it doesn't look linear. It's more like exponential. And then if you're like, hey, what is this line of best fit? You can look at these options. A and B are linear. That doesn't make sense. It's got to be exponential. Now between C and D, with that 2 in there, it's a value larger than 1. We're going to talk about this more in the advanced math section, how to interpret an exponential curve. But right here, that should be going this way. This is going down, and that means that we should have a value in there that should be between 0 and 1, 0.5. So that means in this case, C would be the winner. All right, let's keep it moving. We got 4 minutes to spare. Here we go. All right, now distinguishing between linear and exponential. Linear, you see that consistent change of adding 3, where the x is going up by a consistent value as well. That's that slope. Whereas exponential, the amount we're adding by changes. Now it's multiplying, right? So it's adding by 3, then adding by 6, then adding by 12. But it's a multiplier, multiplying by 2, by 2, by 2, etc. That's the distinguishing factor. Now it could be multiplying by 1.01, right? It could be multiplying by a small multiplier. That doesn't mean it's not exponential. Still exponential. Linear growth would be that nice line. Exponential would be that nice curve. We're going to move it along. We've also got probability and all that good stuff. Watch my video on this because I'm going to jump through this. I think I make it pretty clear in the videos as well for my critical concept Bible. So you can review these slides. Let me jump through this real quick. Make sure we don't miss anything that's very important. Let's go past this word problem. Okay, margin of error, let's talk about this. Margin of error, when you see, hey, we got a sample mean of 72 with a margin of error of 5, what that means is we've got from 67 to 77 is a reasonable positioning or placement of the actual mean, right? So that's what the margin of error implies. If I say we got a sample mean of 72 with a margin of error of 5, then we're like, okay, we say 72, but it could be anywhere reasonably from 67 to 77. Not definitively. It still could be outside of that range. We say it's highly reasonable or highly likely that the actual mean is between 67 to 77. Let's skip this. That was just an example. You can check that later. We're blazing through data inferences. Again, a little proportion, cross-multiplying. Let me just make sure we don't miss anything super important. I think that's the gist of it. Now, for the things that I raced through, I'm sure you're like, hey, what the heck? Again, watch the video. Let me show you the video that I'm talking about. Here, I'll put it up here, and then I got to jump off in 2 seconds. So, doop-a-doop-boop-boop-boop-boo. Oh, wait. SAT Digital Critical Concept Bible. All right, here we go. And if you guys could like this video, we would love you for it. It would be amazing.
That is the name
but look,
of the shape. Now,
so
what makes a quadratic?
So you can kind of go through, and I've time-stamped everything. So for example, hey, where did we leave off? Hey, that data inferences part, you rushed through it really quickly. Boom, click that.
And we get 51.7%. Boom, done. Now we're coming to...
You see, so it goes right to that section, and you can watch me explain it in real time. Now, if anything is unclear, you still have additional questions, make sure, to join our school community immediately. That is right here. The link is down below. You can hit school.com/DSAT. And this is where you can communicate and message me directly if you have additional questions. You can stay up to date on all our class schedules, additional supplemental resources we're going to be posting soon as well. Practice resources, going to be amazing. You got to join. You got to sign up. All right, guys, I got to sign off. Thank you so much for joining. I really appreciate it. Love all of you. Love that you guys are coming hungry, prepared, ready to get this done and show out on October 5th, I believe. All right. Thank you guys so much for joining, and I will see you in the next video. Take it easy.